name is Luke. I'm a junior in mechanical and aerospace engineering, and my fun fact is that I'm on the American Airlines no-fly list.
Hi, my name is Oscar Scholin. I'm a senior mechanical and aerospace engineering student, and my fun fact is I can drive manual transmission.
My name is Vaibhav Kumar. I'm a senior in aerospace engineering. Fun fact about me is I play cricket for WVU.
Hi, my name is Nino Cardenas. I'm an aerospace major currently in my junior year, and fun fact about me, I like cold spaghetti.
My name is Kieran. I am a freshman in mechanical and aerospace engineering, and my fun fact is that I've never been off the east coast of the United States.
For the club as a whole, we compete in the IREC competition and the Argonia Cup. This will be our second year competing in Argonia with our new rocket, Too Dark, Too Dusty. The name is a spin-off of last year's rocket, Dark and Dusty, which we have rebuilt for a test flight this weekend at MDRA. We're going to be flying to test our new Pyrodex igniters and our staging logic. The new rocket, Too Dark, Too Dusty, is a 2-inch min-diameter rocket that's going to be flying a K-2050 to a K-270 to around an apogee of 20,000 feet.
Our rocket is 2 inches in diameter and stands 124 inches tall. We have a SRAD booster that's hand wrapped with 6 layers of 3K carbon fiber. It stands 33 inches long. We have a fiberglass sustainer airframe with 7.5 inches of payload bay, which fits around 10 golf balls, with 24 inches of our drogue bay and 38 inches of sustainer motor airframe that also fits our main parachute. Our couplers are all made out of fiberglass. We are also using a 5:1 carbon nose cone with aluminum tip, which is 12 inches tall.
So for our rocket, Too Dark, Too Dusty, we use 3 sets of 4 fins. 1 set is on the motor side of our booster, 1 set on the motor side of our sustainer, and then a set of canards on our main parachute airframe of our sustainer. Our fins started off as sheets of G10 like this one. We cut them out on a CNC table to make sure all our fins were the same. And then we use a router table for the leading and trailing edges. We then 3D printed and laser cut several different types of fin jigs. And then we used those to ensure that our fins were symmetrical when tacking them to our airframe. When tacking them, we use aero epoxy to ensure that they were structurally sound, and then use 1/8-inch fillets to further enhance our stability. We then use 3 layers of carbon fiber like this, that is 3K carbon fiber, on both sides for our tip-to-tip.
Alright, so for avionics, we're going to be flying a Blue Raven and a Blue Jay in the sustainer and are using a featherweight for tracking. The Blue Raven is going to be the main flight computer that's going to be in charge of the air start E-match igniter, and is also going to be in charge of the main and drogue chute charges. There's also going to be a channel in for backup for the main, as well as cooperating main and drogue backups on the Blue Jay, just for redundancy to have the charges spread out between 2 separate boards. Featherweight will be the featherweights for both the booster and the sustainer are going to be tracking via 2 different ground stations, and also the booster is going to be flying a Blue Jay Plus, which is going to enable us to fire off a separation charge during ascent and bring out the main parachute for the booster during the descent phase.
So now we are going to be talking about air starting. So for our rocket last year, we used motor igniters. However, we encountered some reliability issues. Igniting the motor fried some electrical components. So for this year, we will be using E-matches dipped in Pyrodex as replacement. These E-matches are usually used for deployment chutes. By itself, it cannot produce much heat energy, so dipping them in Pyrodex helps. So far, we tested different amounts of Pyrodex, from thinly coated to noticeably large blobs. So moving forward, we plan to refine our modified E-matches so that we can make it as thin as possible.
for recovery this year, we are flying a total of 3 parachutes, 2 of which are in the sustainer and 1 of which is in the booster. Our sustainer features a 12-inch recon drogue and a 40-inch recon main, while our booster features a 30-inch recon main. All of our parachutes are deployed by air charges that we build ourselves, that are controlled by the Blue Raven flight computer in the sustainer and a Blue Jay flight computer in the booster. All of our parachutes will also be coupled up with a fireproof Nomex blanket just to prevent them from burning up when the ejection charges go off. With this recovery configuration, both our booster and sustainer have a ground hit velocity of 21 feet per second.
So for our simulations for Too Dark Too Dusty, we used both Open Rocket and RAS Aero, the former being the main one that we used to design the rocket. We used Open Rocket for testing out a variety of different motor combinations. We eventually settled on a 54mm base size diameter for the airframe with a 54mm 2560 case for the sustainer and a 1750 case for the booster. So the motors that we're going to be flying for Too Dark Too Dusty is going to be a K270 for the sustainer and a K1100 for the booster. We also have the option for a swappable booster motor with a K2050, depending on the launch conditions and if we get the opportunity to test out a second launch. The sustainer's weight is roughly 11 pounds, accounting for extra mass in the manufacturing process, with 7 pounds in the booster, also with the same, so in total 18 pounds. The thrust-to-weight ratio right off the rail is 15, with the max speed being Mach 1.2 with the sustainer. Apogee is targeted around 20,000 feet, with stage separation happening just after burnout of the booster at 600 feet or 600 feet per second. Our RAS Aerosims also corroborated these numbers with apogees ranging around 22,000 feet and 2,100 feet. The stability margins also were very similar to the Open Rocket, with launch stability of 8 calibers or around 12 to 13, and stability at separation being around 9 calibers or 16%. The sustainer's stability also was right around the 8 calibers or 12% range for both the sims, including with swapping out the motor for the booster as well.